Okay, so we just talked about finding inverses, and we're going to put that into practice. The last two slides that we covered were finding inverses by hand, but if we have a calculator, we could just plug this into our calculator, raise it to -1, press enter, and it will tell us our inverse. And that will be true for any inverse that is invertible. So keep that in mind. First, let's do what is being asked. Find the product. So I'm going to multiply these two matrices. Can I even do that? Remember, I multiply rows by columns. This row has 3 elements. This column has 3 elements. So I can do it. I would do 3 times x plus -1 times y plus 9 times z. And then 2 times x plus 3 times y plus 5 times z. And then 0 times x plus 2 times y plus 2 times z. And it gives me this. Now, this looks like 1/2 of a system of equations. If this product equals these three numbers, then I can say, well, 3x minus y plus 9z equals 9. 2x plus 3y plus 5z equals 0. And 2y plus 2z equals -3. Remember, if two matrices equal each other, they must have the same order, and each element equals its corresponding partner. So this matrix looks big, but it's really just a 3 by 1. There are 3 rows and only 1 column. This whole expression is just 1 element, and it equals 9. So the point here is to help us understand that not only can systems be written as an augmented matrix, but it can actually be written as what's called a matrix equation, where you have the coefficients times the variable equals the answer. And again, this is worth mentioning that with the calculator, you could just RREF the augmented matrix, and you'll have all three of your answers immediately. But the point of understanding inverses is that if you are faced with this, if we express a situation like this is a matrix equation. You want to solve for x. Well, in just being introduced to matrices, your inclination might be, well, just divide both sides by this, because we want to isolate the variables. We want to get the variables by itself. So divide both sides by this matrix. Well, we can't divide matrices, but we can multiply by their inverse if they have an inverse. If this doesn't have an inverse, then we are reverting back to the last section. This has no solution, which means it's an inconsistent system. There's a contradiction somewhere. But I can multiply by the inverse. Now, remember, matrix multiplication, the order matters. So I I have this inverse. You can't just put it anywhere you want. You couldn't squeeze it between the variables and the equal sign, because you couldn't multiply those two matrices. You couldn't take this matrix times this yellow one, because remember, it's rows by columns. This row only has 1 element. This column has 3 elements. And if you try to do that, your calculator will say domain or dimension mismatch. Let's focus on the left side of the equal sign. We'd really love to divide by this, but we're going to multiply by its inverse. And if I multiply two things that are inverses, I get the identity matrix. And this matrix times this is possible because I got 3 elements in this column, 3 elements in this row, 3 elements in this column. So this row times this column will just give me x. This row times this column will just give me y, and this row times this column will just give me z, and I'll have x, y, and z. But since I chose to multiply on the left side, to keep it balanced, you have to multiply on the left side again. So on the right side of the equal sign, you must multiply the matrix on the left side of this matrix. So a lot of students, lots of students don't even really respect that idea, and they just go to their calculator and they do 90 -3 times this, and their calculator won't do it because it's impossible. The order matters. So on your upcoming test, you'll have to show me that this inverse is indeed on the left side of the matrix you're multiplying, just like you introduced it over here. So it's another way of keeping the balance. So here you multiply these two just in your calculator, you get these three numbers, which of course is the solution. RREF told us the solution. So there are two ways to solve these systems. You can RREF an augmented matrix, or you can think of it as a matrix equation and then use inverses to solve. And this is our final example. So two things to do. I have this system and I want to write it as a matrix equation. A times x equals b. So A is the coefficient matrix, x is the variable matrix, and b you can kind of think of as your answer. And then after I do that, I have to solve the system. And they're giving me the inverse, so there's less work for me to do. They told me that with this square matrix, the inverse is this. All right, first, I have to write this as a matrix equation. Well, you have your coefficients 1, 2, 5, 2, 3, 8, negative 1, 1, 2. So that's this coefficient matrix. B multiplied by the variable matrix, and that will in turn equal the answer matrix. And this was our first slide, our first slide. If you were to multiply 1, 2, 5 times x, y, z, you would get this expression, and then set that equal to 2, then you have this equation. All right, so step 1 is done. I've written this system as a matrix equation. Now I need to use inverses. So I really want to divide by this. That's what I really want to do, but I can't. So I multiply by this guy's inverse, and they told me this guy's inverse is this. So I multiply it on the left. That's my only option here. That's the only way I can have the inverse touch this matrix. Since I multiplied it on the left, I have to preserve that. And with this matrix, I have to take the inverse, keeping the balance, multiplying the same thing on the left of this. Now these two are inverses, so I'm told. So I don't have to really multiply this out. I know that if I multiply inverses, I'm going to get the identity matrix. So the left side is just going to be x, y, z. But the right side is going to be another 3 by 1 matrix, and it's going to be my answers for x, y, and z. And that involves multiplying this. So again, we have to multiply the rows on the left times the columns on the right. So 2 times 2 plus negative 1 times 3 plus negative 1 times 3. And I've kind of written it out for you. So this is what you're kind of thinking in your head. 2 times 2 is 4. Negative 1 and 3 is negative 3. And this is another negative 3. So 4 plus negative 3 plus negative 3 is negative 2. And then 12 times 2 is 24, plus negative 21 is 3, plus negative 6 gives me negative 3. And then 5 and negative 2, that's negative 10, plus 9, plus 3. So negative 10 plus 9 is negative 1, plus 3 is positive 2. And here is my answer, negative 2, comma, negative 3, comma, 2, in order triple.